Okay, today we're going to solve a problem which appears in Malaysian IMO TST in 2024, and it is placed in problem 1. So from its place we can know this geometry problem is like interesting but not that difficult. So let's take a look at it. So when we first look at the problem, like let ABC be an acute triangle with orthocenter H. Let B and CF be the altitudes of the triangle. So here we can see that the angles BEC and BFC are all equal. They all equal to 90 degrees. And let's continue. Point P and Q are on rays BH and CH respectively, such that PQ is parallel to BC. So here there are two parallel lines, and the quadrilateral APHQ is cyclic. So what can we get if we connect these points? For example, here AQ AQ and AH. If we connect these 2 points and also AP, these points, so according to the cyclic condition, we can know that this angle HAP equals to angle HQP, right? And also it equals to angle HCB. That's because PQ is parallel to BC. And also we notice that if we extend the segment AH to let it meet BC at one certain point, like G, if it's G, so we can know that AG is also, the angle AGC is also 90 degrees. So we have a circle here. It's not accurate. So like AFGC are cyclic. So that leads to the angle GCH equals to angle GAF. So finally we'll find that AH is the angle bisector of the angle BAP, right? Bisects angle BAP. So that's very important thing that we can get. And let's continue. So according to the things we have, there are two like the circumcenter of two triangles. They are AFP and AQE. So we connect the points to make these triangles. QE is here and FP is here. And also we can connect the 2 points E and F. So in the graph we might find that maybe the lines PQ, EF and AH meet at one certain point. So but we cannot prove that. So actually it's true. So we try to prove that it's true. So where can we start from? Let's just take a look at the angle PAQ. Angle PAQ. Actually it equals to 180 degrees minus angle PHQ. Is that right? That's because APHQ is cyclic, and also because the quadrilateral AEHF is cyclic, so we can know that the angle EAF plus angle EHF also equals to 180 degrees. So that means equals 180 degrees minus angle EHF. Then that equals to angle EAF. So yeah, that's one important thing we can get. So adding the angular bisector, we can find that these two angles that leads to angle QAF equals to angle PAE. Combined with these two 90 degrees, we can find that triangles AQF is similar to triangle AP. So that's one important thing we can get. And thus we can have the ratio of the sides, that's AQ over AP equals to AF over AE is equivalent to AQ over AF equals to AP over AE and plus the two same angles we can have angle QAP equals to angle FAE. So we can get the triangles AQP similar to the triangle AFE, and also it's similar, obviously it's similar to the triangle ACB. So we can get these three similar triangles, and since we have these things, we can try to prove that the segments PQ, EF, and AH meet at one certain point. We can denote, let's copy the graph again. We'll paste it here. Okay, so we denote the point as L. As L. So denote that EF meets PQ at L. So according to triangle AQP similar to triangle AFE, what can we have? So the thing we can get is the angle AQL equals to angle AFE and equals to angle AHE. Thus, these two is because AE, HF are cyclic. So yeah, and plus where can we get it? Plus the angle bisector, the angle QAL equals to angle HAE. So we can have the triangle AQL is similar to the triangle AHE. So what can we have? That means the line. That means the angle ALQ equals to angle AEH equals to 90 degrees. That means AL is perpendicular to PQ. So, and also we have noticed that AH is perpendicular to PQ. So L lies on segment PQ, and that leads to AH, PQ, and EF meet at one point. So that's great to see that. And after having these, we can know that the angles HFE, where is it? It's here. HFE equals to HAE is here, equals to HAQ is here. So since we have this HAQ, that leads to FLAQ cycling. Yeah, that's right. So we can have, we use there's another copy. This point, this point is L, so we can have the angle FQP equals to, FQP is here, equals to angle FQL. Sorry, it's not here. FQP is here, the blue angle, equals to angle FQL. That's because L lies on PQ and E equals to the angle FAL. That's because FLAP are cyclic, and that equals to angle FAH. Yeah, L is on AH, that's obvious, and that equals to FAH equals to FEP. That means we have these two angles of the same degree, so that leads to FQEP cycling. So that's important. After having this, what can we get? We might think that X is a certain point, so we can use another page to explain this. No, here. We do the connect the point. Okay, so notice that we might think x is a very certain point, because in a graph, if we do it strictly, we might find that x is the center of the circle QFPE. Maybe that's only an assumption, so we try to prove that. So so we can denote the center of the circle QFPE as maybe letter Y. So maybe it's here, who knows? So we can know that the angle QYE is here. So if we find another point Zach on the major arc QE, we can find that it equals to 2 angle Q Zach E. So that means it equals to 180 degrees minus angle QPE. Is that right? So n equals to angle QPB, and according to the parallel lines we have, so we can get the angle QPE equals to the angle EBC, right? So EBC, and also if we extend it same to G, we can know that AEGB are cyclic, so the angle EBC equals to angle EAG, so 2 EAG, and also equals to the angle QAE. So we know that Q, Y, A, and E are cyclic. So in the same way, F, A, Y, and P are also cyclic. So that leads to Y equals X. So they are the same point. So X is the center of the circle QFPE. So now the problem gets easier. So the angle XAB equals to the angle XAF. XAB equals X. That's it's all obvious. So equals to XAF equals to XPF. That's because of the isosceles triangles. So XP not the isosceles. That's because of the side circle we have. XPF and equals to half of the 180 degrees minus FXP. So equals half of 180 degrees minus FAP equals 90 degrees minus angle BAH equals to angle BAC. so that these two XA parallel to BC. So that's end of the problem. Thanks for watching.